Hello everyone. In this video we're going to be working with an exponential system. We have 5 to the power x equals 27 and 3 to the power y equals 25. And we're supposed to evaluate xy. So we're going to be finding a numerical value for x times y. I'll be presenting two methods, but I'll probably show you the third one as well real quick. Let's start with the first method. So for my first method, I'll be doing the following. We're given two equations in exponential form. I'd like to turn them into logarithmic form. And then for this, I'm going to use natural log, which is ln. So start with 5 to the power x equals 27 and ln both sides. If you ln both sides, you get ln 5 to the power x equals ln 27. And now, since we have ln, we can go ahead and move the x to the front and write this as x times ln 5 equals ln 27. This allows you to express x as a quotient of ln's. So now x can be written as ln 27 over ln 5. Now we can definitely go ahead and simplify this. Since 27 is 3 to the third power, I can write this as ln 3 to the third divided by ln 5. And again, one more time using the property, we can move the exponent and write this as 3 ln 3 divided by ln 5. So that is my expression or value for x. Let's go ahead and do the same thing for y, and then we're going to put it together. Okay? So now we have 3 to the power y equals 25. ln both sides. ln 3 to the power y equals ln 25. By the way, you don't have to use natural log. You could also use common log, which is log, which is base 10. So let's go ahead and move the y to the front, and that's going to give us y ln 3 equals ln 25, and then y can be written as ln 25 over ln 3. And since 25 is 5 squared, we can simplify it, just get to the bottom, and from here y becomes 2 times ln 5 over ln 3. So we got numerical values for x and y, but we don't really care what they are. I mean, you can use a calculator, evaluate x and evaluate y. Obviously, there's going to be some error in calculations, and then you can multiply them. Hopefully, you'll get pretty close. Maybe you'll get the exact same answer. Let's see what happens. So we got the following values. Summarize. X equals 3 ln 3 divided by ln 5, and y equals 2 ln 5 over ln 3. And don't let it look like 21. This is ln. Okay, so those are the values that I got, and I'm supposed to evaluate x times y, which is xy. So let's go ahead and multiply these expressions. 3 ln 3 over ln 5 times 2 ln 5. Maybe I'll split them up a little bit so they don't get mixed up. Divided by ln 3. Okay, notice that ln 3 divided by ln 3 is equal to 1. So these two cancel out. ln 5 cancels out. And what is 3 times 2? 6, right? So the answer is 6. Great. It was that simple? Well, with the log, it's simple, but with second method, it's going to be even simpler. So here's the second method. And after that, after the second method, we'll talk about a third alternative. So we have, one more time, 5 to the power x equals 27. And 3 to the power y equals 25. So I'm going to go ahead and write the 27 as 3 to the third power. And then from here, I would like to isolate the 3. So let's raise both sides to the power 1/3, or cube root, in other words, right? We can cube root both sides. And the 3 cancels out. And we end up with 5 to the power x over 3 equals 3. So what am I going to do with this, right? So 3 equals something in terms of x, and I have a 3 here, so I'm going to go ahead and substitute. Let's replace 3 with 5 to the power x over 3. That's going to give me 5 to the power x over 3 instead of the 3 to the power y. That comes from here, equals 25. Now we're supposed to multiply the exponents, right? That's going to give us 5 to the power xy over 3 equals 25. 25 can be written as 5 to the second power. And by setting the exponents equal to each other, we get xy over 3 is equal to 2. And finally, xy equals 6, as before, right? So that is the second method. Let's go ahead and talk about a third approach, which you can call third method if you want. I don't know. And this is what it looks like. So 5 to the x is 27. 3 to the y is 25. So now, the first one I was able to write as 3 to the third, and this one I was able to write as 3 to the y equals 5 squared. So kind of look at these two equations. Wouldn't that be nice if I was able to isolate one of them and kind of plugged in or substitute? So here's what we can do. We can go ahead and isolate 5 from here. Like we can write the 5 as 3 to the power 3 over x. And from here we can write the 5 as 3 to the power y over 2. So these are both equal to 5. If two things are equal to the same thing, then they're equal. So 3 to the power 3 over x equals 3 to the power y over 2. And that implies 3 over x equals y over 2. And from cross multiplication, this just means that xy is equal to 6. Alrighty? Okay, great. Even though I said that I was going to introduce 3 methods, let's go ahead and talk about an alternative approach. If you want, you can call that fourth method. Okay, great. I just wanted to share with you. So we have 5 to the x equals 27, and 3 to the y is 25. So we can log both sides, but this time we can use base 5, right? That is going to give us base 5. And then this x is going to be moved, and log 5 with base 5 is just going to be 1. So we can write this as x equals log 27 with base 5. So that kind of gives us a nicer value. Instead of a quotient, we can write it as a log of something. From here, we can log both sides with base 3. And because our base is 3, that makes sense, right? We can go ahead and move the y. Log 3 with base 3 is 1. So that's going to become y equals log 25 with base 3. So I'm supposed to multiply these to keep a long story short. Since I'm looking for xy, I can basically write this as log 527 times log 325. So how do you simplify something like this, right? So there's a couple of ways to go about it. You can basically do very different things here. First of all, you can go ahead and move this as an exponent, for example. Since we can move it to the front, we can always do the opposite. So xy becomes log with base 3 of 25 to the power log 27 with base 5. And then we can write this as 5 squared, right? And then raise it to the power that. And then we can kind of multiply that by 2 and write it as 2 times log this. And then we can kind of move it over here, log 3, and then 5 to the power log with base 5 of 27 squared, which is 729. Now notice the property that we talked about. A to the power log b with base a is always b. So here the answer is just going to be 729. I mean, this part is going to be 729. So this is going to be 729 with base 3. But 729 is 9 to the third, which is 3 to the 6. And that is going to become, because 3 to the 5th is 243. So this is 3 to the 6. And this becomes 6 as before. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.